Hi, we are now going to see Euclid's geometry part 3. Collinear points. That means points lying on the same line are called collinear points. Three or more points are said to be collinear if there is a line which contains all these points. Concurrent lines. Concurrent line means all of them have a common point. Three or more lines are said to be concurrent if there is a point which lies on all of them. Parallel lines. Theorem 1 we will see. Two distinct lines cannot have more than one point in common. We will see that. Let us assume that they are having more than one common point. Two distinct lines L and M have two distinct points P and Q in common. We are assuming the opposite. We will prove that it is not possible. Line L contains 2 points P and Q. Line M contains 2 points P and Q. But there is one and only line passing through two distinct points P and Q. Given 2 points, there can only be one unique line. That is our axiom. The lines L and M have to be coincident therefore, because it's a unique line. This contradicts the hypothesis that L and M are two distinct lines. So this is not correct. Therefore, two distinct lines can have at most one point in common when they intersect. And when they are parallel, there will be zero common point. Intersecting lines. See, the two lines are intersecting. There is only one point in which it can intersect. Two lines are intersecting if they have a common point. This is a common point. The common point is called point of intersection. Parallel lines. That means no point of intersection. See, these are the parallel lines. Two lines L and M in a plane are said to be parallel lines if they have no common point. There is no intersecting point here. Two parallel lines do not intersect. These two parallel lines will never meet. L is parallel to M. This is how you denote. It means line L is parallel to line M. Parallel lines, we will see one more axiom. If L is a line and P is a point not on the line L, that is point P is not on this line, it is somewhere else, then there is one and only one line which passes through point P and is parallel to L. That means through point P we can draw only one unique parallel line. Two intersecting lines cannot be parallel to the same line. Now we will see another theorem. Two lines which are both parallel to the same line are parallel to each other. Consider three lines L, M and N such that M is parallel to L and N is parallel to L. Therefore, M should be parallel to N. We have to prove this. Let us assume that M be not parallel to N. M is not parallel to N. That means M and L intersect. Then M and N intersect at a unique point, say P. So thus through a point P, not on the line L, there are two lines M and N parallel to L, which is not possible because it's a common point for M and N. And we say that there are two lines through the point P, which is not on this line L. Two lines cannot be parallel and then intersecting here at the same point. Thus, this contradicts the parallel axiom we studied in the previous slide. Therefore, if M is parallel to L, N is parallel to L, then M and N are parallel to each other. So, therefore, M is parallel. We will see another theorem. Theorem 3. If M and N are lines in the same plane such that L intersects M and line N is parallel to M, then L intersects N also. Right. That is, L, M, N are there. L intersects M and N is parallel to M. Therefore, L should intersect N also. Let us assume that L and N be non-intersecting lines. L and N are non-intersecting, we are assuming. That means L and N are parallel. Then L is parallel to N and N is parallel to M. Therefore, L is parallel to M. That means L is parallel to M means L and M are non-intersecting lines, but L is intersecting M. Therefore, the assumption is not correct. This contradicts the hypothesis, that is the statement L and M are intersecting lines. Therefore, our assumption is wrong. That means L and N are intersecting lines. Therefore, if L intersects M, L should also intersect N because N is parallel to M. Another theorem we will see. If L and M are intersecting lines, so L and M are intersecting lines, L is parallel to P, this L line is parallel to P, and M is parallel to Q, then P and Q also intersect. That means this P line and this Q line also intersect at this point here. We will prove that. L and M are intersecting lines. L and M are intersecting lines. L is parallel to P and M is parallel to Q. L is parallel to P and M is parallel to Q. That is what is given. L and M are intersecting lines. L and M are intersecting lines. And L is parallel to P. Therefore, M and P also intersects by axiom. M and P are intersecting lines. M and P are intersecting lines. That is what we have just seen now. And M is parallel to Q. Therefore, P and Q also intersect. Because M and P are intersecting lines and P and Q are parallel lines. M and Q are parallel lines. Therefore, P should intersect Q also. Because Q is parallel to M, which is intersected by P. Theorem 5. If lines AB, AC, AD and AE are parallel to line L, then points A, B, C, D and E are collinear. You will see that very easy. Lines AB, AC, AD and AE are parallel to line L. Point A lies outside L. There is a point outside this line L. And through A, lines AB, AC, AD and AE are drawn. Right? But by parallel axiom, one and only line can be drawn parallel to L through a point A. And that point A is not on the line. That is what he said. Therefore, A, B, C, D and E lie on the same line because it's a unique line through A. Therefore, a unique line through A contains B, C, D and E. Therefore, they are collinear. Line segment. Given 2 points A and B on a line L, because you know line means goes on both the directions, infinite length. The connected part of the line, that is that segment of the line with the endpoints A and B, including A and B, is called line segment AB. We can denote AB with a bar or BA with a bar, all are same. It has no direction. Interior point of a line segment. Congruence line segments. We will see these two now. Interior point of a line segment. A point P on the line segment AB is called interior point of line segment AB if the point P lies between A and B, but P is neither A or B. So the point should be on this line AB, but it should not be A or B. A and B are called endpoints of the line segment AB. We will see congruence of line segments. Two line segments AB and CD are congruent if the trace copy of one, that is either AB or CD, can be superposed on the other, that is AB on CD or CD on AB, so as to cover it completely and exactly. A trace copy of AB if placed over CD will cover CD completely and exactly. Similarly, a trace copy of CD if placed over AB will cover AB segment completely and exactly. Properties of congruence of line segments. AB is congruent to AB. This is how it is notated. Notation is given. AB is congruent to CD means CD is congruent to AB. AB is congruent to CD and CD is congruent to AF means AB is congruent to AF. Implies. Line segment length we will see. Axiom. Every line segment has a length measured in meter or its parts. What do you mean by part of meter? Centimeter, decimeter, millimeter, like that. Axiom. Another axiom. Two congruent line segments have equal lengths. AB is congruent to CD means length of AB and length of CD are same. Two line segments of equal lengths are congruent. If AB is equal to 2 cm, CD is equal to 2 cm, then AB and CD are congruent. Because it covers exactly and completely. Third axiom. AB is congruent to CD means length of line segment AB is equal to length of line segment CD. Two line segments of equal lengths are congruent. That is what we have seen here. Line segment length. Axiom. If C is any interior point of a line segment AB, then length of line segment AB is equal to length of line segment AC plus length of line segment CB. Because that means C is dividing the line segment AB. Therefore, AC plus CB should be equal to length of line segment AB. Another axiom. Given a point O on a line and a real number R, then there are exactly 2 points P1, P2 on the line L on either side of O such that OP1 is equal to OP2 is equal to this real number units, R units. I will show it to you here. See here, there is a number line, point O is there, and R length we are taking on the left hand side and right hand side. Left hand side R unit is equal to P1, right hand side R units we get point P2. So AB is congruent to CD means length of AB is equal to length of CD. Or if length of AB is equal to length of CD, that means AB is congruent to CD. That is implication on both ways. Distance between 2 points, we will see more. Distance between 2 points P and Q is the length of line segment joining them. Distance between 2 points P and Q is denoted by PQ. A point C is said to be lying between A and B if A, C and B are collinear and AC plus CB is equal to AB. Only if these two conditions are met, then the point is said to be lying in between A and B. That is the interior point. Midpoint of line segment. If AC is equal to CB, then C is the midpoint. AM is equal to MB, M is the midpoint. See, AB is the line segment, M is the midpoint, length AM is equal to length MB, therefore M is called midpoint. A point M is said to be midpoint of AB if M is the interior point of AB, that is condition number 1, and condition 2 is AM should be equal to MB, and AM plus MB should be AB. A line through M other than line AB is called bisector of AB. Please note I put only two conditions because AM is equal to MB, AM is half of AB, therefore AM plus MB should be equal to AB. That is why that condition is not mentioned. Midpoint we have said, no. A line through M other than line AB is called bisector of AB. That is any line through M, that means that line bisects AB into two parts, equal parts. Ray. We will see what is a ray. A line with one end point called initial point is called a ray. That means there must be an initial starting point and it goes infinitely in one direction. Consider a line L with points A, B and C. Here I am just marking a point O and deleting this point, right? AB and AC are two rays here. Note, AB and AC are two rays. AB is one ray, AC and two rays. A is included in both rays. And AB and AC are opposite rays because the direction is opposite. Offline we will see. Consider a ray AB with initial point A. You know how it is looking. This is a ray. This point is included. If this point is not included, then it is called offline. Point A is included in the ray here. If point A is not included in the ray, then it is called offline. Right. We don't call it as line segment. It is offline because it goes in one direction. Point A is not included. That means if the circle is empty, that means the point is not included. The circle is dark, then it is included in the ray. If A, B, C lie on a line L such that A lies between B and C, deleting the point A from the lines gives two offlines AB and AC. So I will take a line. If the point A is not included in the ray, it is called offline. See, I have taken a line, taken a point, I have deleted this point, then it is called offline, offline. Offline AC, offline AB. But point A is not included. Point C is included here in this offline AC. Point B is included in the offline AB. Now we will see off plane. Consider a plane. This is a full plane. Alpha is called. So consider a plane alpha. Consider a line L on this plane. Line L is on this plane alpha. Now L divides this plane into two halves. And there is a point on this plane which is not on this line L. Right? The points on the plane other than those on the line, that is line L, form two half planes with edge in L. Right? So all these points here in this plane, all these points here on this plane, excepting the points on the line, form two half planes. Right? This is a point here on this half plane. So a point C on the plane will lie in one half of the plane, one of the half planes only. It cannot lie in both half planes. Right? Though it is lying in the plane, once you split into two half planes, the point can lie in only one half plane. The half plane 1, that is this half plane 1, containing the point C is denoted by H open bracket L comma C. This is the half plane, this is another half plane. Right. That completes Euclid's geometry. We will see Euclid's geometry part 4 quiz portion in the next session. Thank you very much.